Thanks everybody for joining me. My name is Steve Poyer. I'm a solutions engineer with Cast AI. And in this presentation, what I'm going to be talking about is something called container live migration and why that's important and what problem it's solving. Can I get a show of hands? How many people are supporting working with Kubernetes? Okay, awesome. Because that's part of the story for sure. So to start off with a little bit about me, some fun facts. I started off my career in the US Air Force, working in the space part of the Air Force. So I was a space cadet. I have a Duolingo streak of 1,070, whatever that says. Any Duolingo fans here? All right, awesome. Mostly Spanish, but some French and Italian also. And I have an Apple move ring streak of 1,358 days as of today. Today will be 59. All right, all the Apple fans out there. All right, so that's me. Cast AI, the company I work for, what do? We give you insights and visibility into what you're spending in your cloud environments. And in particular, we focus on Kubernetes, but we also can help out with database usage as well as network usage, storage. Then we show you what it is that you could potentially be saving in that environment. So we see what you're spending. We see what we think you could be spending if you were more efficient. And then we don't stop there. We actually implement optimizations through automation, machine learning, to help you realize those savings. And so in this talk, it will be related. And what I'm going to be talking about is in the context of that larger picture of what we do. So what does that look like? In practice, if you look at it on the left, this is what we see oftentimes in the before case. The top line, the blue line, represents what it is that has been provisioned. And in this case, in particular, we're talking about CPU. The yellow line down below is representative of what all the applications within the cluster are actually requesting. And what we try to do is over on the right there, which is bring those two values more in line, because the vertical space in between those represents money that you're spending, but not actually using. So that's the before and the after. So what is it? How do we achieve that? Largely what we do is we move workloads around and more efficiently pack them into the nodes of the cluster. And what prevents us, or what are some of the blockers that could prevent us from achieving that? A lot of times what we see in clusters are these legacy applications. So for example, I'm working with one customer in the video space. They've basically taken their monolithic application, put it into a container, and they run one container on one node. Not really what you'd think of as a modern application, but generally speaking, these problematic workloads fall under the heading of what we might call a stateful workload. So everyone probably working in Kubernetes knows about the concept of a stateful set. And sure, that's one example of that, where you might have storage, making it difficult to move those workloads around. But we also have, again, this idea of some of the legacy apps, things that might have been written originally in Java, maybe some .NET, things that take just a long time to start up. So we see instances of these workloads that might take up to 15, 20 minutes to start up, making it problematic to try to move that from one node to another. And then we also have this idea of applications that are maybe more stateful from a networking perspective. So things that are running, for example, WebSockets, where you have users who are relying on that connection to stay intact. Otherwise, the experience from the client end might be harmed. So we think about this stateless versus stateful types of applications. Stateless, typically modern applications, they're run, maybe it's a 12 megabyte, it's a microservice architecture. That's what we typically think of as a stateless application. You could take one of those pods out, no big deal. The application is going to still run fine, and user experience is not impacted. Stateful, on the other hand, some of the things that I've already described. If you were to try to move those, you're probably going to impact the end user experience somehow. And the metaphor that commonly gets used between these more legacy type stateful applications versus modern is pets versus cattle. right? You've probably heard that before. Pets, we want to take really good care of. We care a lot about them if something were to happen to them. Cattle, if you lose one, not as a deal. And so that's I think, an apt metaphor. So what's the effect of not being able to move these types of apps? All right, this is another version of the graph I started and showed you earlier. And if you look inside that gold rectangle, what we've done here, let me back up and talk about what this graph is showing. So at the very bottom, that green layer, that's representative of what the applications in the cluster are actually using. And again, this is from a CPU perspective. We do this for memory and other resources as well, but we tend to focus on CPU since that tends to be the most costly of the resources. So what we've done, okay, and then the blue shading, that's what the applications are requesting. So you can see already that there's this disparity between what the applications are requesting and what they're using. And inside the rectangle, you see a drop in terms of the request. And that is brought about, and this is an actual customer environment, but that drop in requests is brought about by what we call workload right sizing. So we've implemented that level of optimization, but that top line in terms of what's being provisioned is representative of all of the nodes, all the CPUs across all the nodes that make up the cluster. And you'll notice that line is not dropping nearly as much. All right. And the reason for that are these problematic applications, these staple apps that we can't bin pack, we can't move them around because potentially that's going to have an adverse effect on the running of those applications. So one way that customers have tried to address this is they might take a set of nodes in a cluster and just cordon those off to only run those stateful applications. And it becomes somewhat of a ghetto within the cluster where we've got these problematic workloads. We're just going to put them over here. We'll have everything else run on these other nodes that we can swap out at will and that we can redistribute workloads. And so that's an approach that can work. It's not great. It has some drawbacks. Specifically, it makes it difficult to update, for example, the Kubernetes version of those nodes. So it just makes, generally speaking, the maintenance and the upgrades. And so you end up with a bunch of unaddressed CVEs, for example, which could have some security consequences. So this is an approach that we see some customers taking, but maybe there's a better way. So enter this concept of live migration. And it's specifically meant to address this idea that we have stateful workloads that can't easily be stopped, can't easily be moved from one node to another. The result of that is that you get fragmentation, you get workloads that are running and underutilized, essentially, nodes running in your cluster. And so for folks like you that are responsible and are being asked to maintain these types of applications, and at the same time, you're being asked to help bring down costs by running things more efficient, you're stuck in the middle of those two competing desires. What we've done is to develop this capability of live migration. And the idea here is that we can take these types of workloads and move them without actually having to stop them. So we can take a pod running on server A, and without having to stop it and restart it on server B, we can move it in a live way that maintains the state of the application, maintains all the connections, and as a result, gives you a way to now optimize those clusters, make them run more efficiently, get more out of what you're paying for. So that's why we came out with this concept of live migration and what it does. To get into more of the details about how it actually works, this comes about in a process where there's a piece of technology that we call the evictor. And the evictor is constantly looking at each node in the cluster and saying, if I were to remove this node, would all the pods on this node end up on the remaining nodes in the cluster? The evictor now has this capability to then do an analysis and say, is this workload, does it make sense to live migrate it instead of actually stopping it? So that's the first step in the process. The second step is that if that's the case, what we're going to do is to take the state of that pod, that container, so both the memory page as well as the process state, and we're going to replicate that within another pod where we've changed the name, but that other pod is on, of course, a secondary node. What we've also done is we've taken the AWS VPC CNI, we forked it, and what that's allowed us to do is to maintain that same IP address of the new pod that is landing on that new node. And so that's what allows us to maintain those network connections. Then finally, before the switch is made, there's a final change of any additional state, and there's a brief pause that takes place as the old pod is terminated and the new one is now become the live pod. And depending on various things like the storage and so on, that pause could be longer or shorter. There's certain factors that are going to lead to how quickly that happens. But for modern applications, that switch over is almost simultaneous. And again, all of the state, the process of where that application was running stays the same. All the connections, the client connections are maintained across that live migration occurring. All right. So that leads us to a demo. So in the title of this presentation was a practical demo, and this is maybe practical, maybe not. So what I have here is, and we'll see if this works. This is always the tricky part of running a live demo. But this is an instance of Minecraft running in a pod. And you can see it's actually live. Fortunately, it's only a small part of the window there. But you can see as I move my cursor around, the background changes, and I can try digging and so forth. I don't know. How many people have played Minecraft in the audience? I never had. So this is, you could probably do better than I, but you see the QR code, you could actually join the same pod if you'd like to. No requirement to do that to see the demo. And this is actually a capture the flag version of Minecraft. So you guys could actually start to play, and we see the numbers come up here. Now, the two nodes that I have here, you can see are represented by the green Kubernetes logo and the blue one, currently running on green. And down here at the bottom, we can see the actual node that it's running on. And so the workload here is this capture the flag server. And it currently has an IP address of 51.1.115, and it's running on the node currently 39. So I can force the live migration. And so what it's going to do is to take that pod, that workload, and it's going to move it over to this second node, 149. So again, currently running on 39. You can force that migration by clicking here, and there is a change in the color of that icon, but I'm still playing the game while this pod is actually being changed and moved over to the other node. And okay, so still running. Okay, and it looks like the migration has finished. So if I come back down here, and we can see now that my pod's same IP address, but now running on node ending in 149. So you just saw an actual movement. Let's see. Doesn't look like anybody else has joined, but that is actually my quote unquote practical application of live migration. But again, in the real world, what this is helpful for is helping to optimize all your clusters, allows us to move around these stateful workloads, these legacy applications, make the clusters more efficient. And with that, I'd like to open it up for questions. And yes, sir, we have one here in the front.
So back on your live migration slide, first of all,
Questions.
So on your live migration slide, you were showing that you had one instance of the shared data. For reliability and for just performance reasons, would you want to have multiple versions of that, or do you support anything like that?
Multiple versions of the workload?
Multiple instances of your shared data storage. So let's say that for some reason, one of that just doesn't load, and that extends your swap over time. Let's say that you had two others attempting to get up or be in place at that time, probably a little bit more reliable. I don't know. How do you guys address that?
Yeah. So usually what we would see is some sort of a network attached storage. So potentially NFS. And so there's some advantages of NFS versus using, for example, PVC backed storage in that you can have a multi read write storage type. That's probably the optimal in terms of this particular scenario and supporting this idea of live migration. However, we do support using PVC backed storage as well. We have a listing on our site in our documentation of all the different storage that we do support. So we don't so much in terms of recommendation on what the storage is. We kind of leave that to the experts in the application and what makes the most sense. But hopefully that helps to touch on your question. Yeah.
Okay.
Other questions?
Hi, Steve. So one question on, you mentioned the criteria that is used to decide whether a certain node is qualified to migrate or not. What does that look like, the criteria to qualify?
Yeah. So actually what I was referring to in that, I'll answer the question, but what I was actually referring to was whether the pod itself was a good candidate for live migration. But in terms of the node itself, there are some restrictions on that. So the way we think about our autoscaler is it's a cost-aware autoscaler. And so we're typically choosing what is the most cost-effective instance that we can pick to add to the cluster. However, in the case of live migration, it becomes more important that the nodes that you're moving between are, for example, of the same generation. So that's, you would want a similar architecture between those nodes. And so that's one of the restrictions, and we help you set that up as part of something that we call our node templates. You would create these restrictions on sticking to at least the same node families, for example, that are going to have similar processor architectures. So that's probably the most important thing.
Hey, Steve, my question is around this live migration. When we perform this in the real time, do you recommend that we need to halt the IO operations before initiating this live migration to preserve the data consistency?
Yeah, that's a great question. In the case of, there are cases where there's potential conflicts with things like Argo. We address where those conflicts are. Where that does tend to come up the most is in our workload right sizing. So oftentimes when you have infrastructure as code, you've got specific requests and so forth that have been set that are in your Git, for example, and we're changing those. So that's where the potential conflicts come up. But with actually just moving the pod itself, I don't think there's going to be a conflict there, but maybe there's something I'm not thinking of. So I don't think that with something like Argo, values that would be stored in Git, for example, are being changed there that are going to create a conflict. But maybe you have something specific in mind that I hadn't thought of.
This is more around like when a pod is performing some write operations where it has locked the files, where the number of open files on that node, on that pod would be in the high count. When I try to migrate that data, then it's going to create a conflict. That's the reason why I was talking about.
Okay.
As a precautionary.
So local node storage, in other words. Yeah. Yeah. There are some limitations around storage. I'd have to go back and see if that was one of them, but that's a good question. So if you do have local storage and that node, for example, is going away, then that's obviously going to be a problem. And that's, I suppose, independent of what the CI/CD tooling is around that.
So here the shared storage is, you talked about NFS or the EFS, right?
Yeah.
Okay. Yeah, thanks.
Yep. I'm sorry, the what's associated with it? IP addresses, yes. It's the overlay
Steve,
network.
do you mind repeating the question for the recording?
Okay, sure. Yeah, let me know if I got this question right, which is that in AWS, you have IP addresses that couldn't be replicated. Is that the basic idea? Yeah. And so that's part of what we've been able to get around by forking the AWS VPC CNI. And so that's let us that's allowed us to get around some of the restrictions specifically within AWS. And by the way, this functionality that I showed today is currently only running in AWS. We have plans to make it available in GCP, GKE, sometime this quarter. But that's how we get around that limitation.
So in the demo you had, the live migration took only a few seconds. Are the data transferring within the same host or are they different host?
They were different hosts. So the movement, yeah, good question. So the movement of the container was going from one host to another.
And the data was transmitted through public internet?
I'm sorry, say again.
The data was transmitted through public internet?
No, this is all contained within a cluster, within an individual cluster. So it's only going over the network that's supporting that cluster.
Okay. The reason I'm asking is that I was thinking of one use case where we say we're building a bunch of things with a cluster service, and then there was another vendor that offers a cheaper price. So we would like to use their resource, but currently we cannot cancel our current in progress jobs. Because we don't want to redo everything over, even if the newer resource is cheaper. So I'm thinking if I try live migrate my job from one provider to another provider, I have to do it within public network. So would the speed be fast enough to save money? Do you think that makes sense?
That is a great question. And so we're actually coming out with a technology that we call Omni that's meant to address exactly what you're talking about, which is to extend Kubernetes clusters to other providers. Now, when we'll have live migration for that Omni product, I'm not sure. But you do bring up some tough challenges there, definitely. And there's definitely limitations in the product today that would not support the scenario you just described. But we are, I would say, developing with that exact same idea in mind of being able to take a running job, move that to a less expensive environment in a completely different cluster, completely different cloud provider.
I see. Thank you.
Yep.
All right. Any more questions? All right. Thank you very much.
All right. Thanks, everybody.